In this video, we're showing the first air-to-air radar test on a small drone using Echodyne's metamaterial electronically scanning array radar. Echodyne's radar is mounted on a small octocopter drone. The drone will lift off and ascend to just under 400 feet. A second drone carrying a radar reflector that simulates a Cessna-sized object will then take off and fly into the same airspace. The Echodyne radar will search the airspace to detect and track this drone. The Echodyne radar is capable of scanning 120 degrees horizontally, although in this particular demo, we set the radar to scan 90 degrees. The radar image is on the left side of the video, and a webcam with slightly narrower field of view is on the right side for comparison. As soon as the drone carrying the radar lifts off, ground returns start to show interesting data. In this frame, you can see two barbed wire fences running across the field of view. Seeing a barbed wire fence is important because it also means the radar can see power lines, which are a major threat to small drones flying at low altitudes. As the drone gets higher, some individual objects on the ground still stand out. You can also see trees and other structures differentiated from the grass fields. At higher altitudes, more general structures are visible. For example, the outlines of fields versus the tree rows between the fields are clearly differentiated. Now that the drone is hovering at elevation, a second drone takes off and enters the airspace from below. The radar detects the new drone and uses a tracking algorithm to track it as it moves through the airspace. The radar does an excellent job of picking out the drone from surrounding clutter. Scanning in elevation helps with this. For example, here's the radar data when Mesa is scanning down. And here's the same frame looking horizontally, where the drone is more clearly identified. As the radar tracks the drone through the airspace, try to locate the drone in the webcam image. You'll discover this is hard or even impossible to do. Cameras are fine at seeing things nearby and in good weather, although they don't actually measure the distance to the object. Radar, on the other hand, does measure the distance and does so at long ranges and in poor weather. This is why it's the clear sensor of choice for all weather safety systems. The radar used for these tests is Echodyne's Mesa Developer Kit radar, which was designed to track a Cessna out to 500 meters. Echodyne's Detect and Avoid radar for small drones has a range of up to 3,000 meters for a Cessna-sized object and up to 750 meters for a small drone. While this video shows the Mesa radar tracking a drone, Echodyne also completed similar air-to-air tests tracking a Beechcraft Bonanza and an ultralight aircraft with similar results. Now that the drone has made a number of maneuvers through the airspace, it descends out of view and lands, successfully completing the test.